afternoon. Hey, let's hear it for Tangela and those little movie makers. Wonderful we can do things like this. We're going to go to the slides. I have not as many slides as I normally do because I would like to have some time to talk. Is this a little bit too loud?
Yes.
Yeah. Maybe you guys could turn it down a little bit. Thank you. Can I talk loud and I'll walk back and forth and give you a little bit of tennis whiplash here. We're going to the slides, I need to push the button. So, I really am quite privileged to be here this afternoon. Probably most of you do know that I'm on my first farewell tour. I'm retiring from government service next Friday, my last day. I've been in town for 5 years now in Washington, and the year before that as a contractor. And this is my third or fourth time here. And I have my wife of 49 years back there with the camera. She and I actually had our honeymoon down the road here in a place that's now the Senior Center for Bedford. We could go there again. Back in those days, it was the place. This place was in a very bad disrepair, and then it was closed for 20 years. So that was the place to go. We lived in Little Washington. Those of you who know about the area here, it's not far. People come here because this is like midway between Pittsburgh and Washington, D.C. So it's very convenient and a beautiful place. That's why we were here back in those days. And so I couldn't miss the opportunity for my last time here in this suit to bring her here. So thank you for that round of applause. I'm going to be talking not about hitting an altitude and airspeed. That was the subject of the video. It is on YouTube. Go to YouTube and put my name in there. You'll see that one and the 3-minute one that we showed last year and a couple other little things that the people have done. I expect that the work that I'm doing will continue when I'm departing the department with people like Didi Akeo right here, who's still there. Eric Raytort is now with DISA. He's here. You're going to see Jonathan Underley on Tuesday. Actually, he'll be here later. So the team is there, and they know how to do this technology stuff. I'm sure they'll continue. Beth McGrath, of course, is still in her place. I've had the privilege of working with her for the last 5 years. So we're talking about the semantic web. I'm going to take you a little bit down history lane, my privilege my last time here, but then leave you with where this should go in the future. So we're talking about our history of point-to-point interfaces and it's an N-squared interface, practically exponential growth. And as the video says, we can't afford to do that anymore. Number of queries increases every time we get a new data store, and we keep piling those data stores one on top of another. This isn't my picture. We're going to show you our answer to this picture. This is linear connections, 2 to the n minus 1. So at worst, it scales 1 to 1. At worst, unlike what we've done in the past. We've been able to get these queries done because we've lived through relational data stores, through DBMSs. I was a pioneer in that technology. Those days are over. We can tweak the hardware to get more performance and do funny little tricks with the software, but it's ending its lifetime. This technology is a whole different game changer. These links, I'm going to show you the real example. These links are URIs, the equivalent of semantic technology of the URLs. And even better than that, I'm going to show you an example at the very end of this of how Siri works. These are force-directed graphs. It not only gets you in the vicinity of where you want to go, it gets you where you want to go because it knows where you are. Point-of-presence technology. You all have one in your pocket right now. So it's just a whole different kind of thing. Big data. We had a person from Cloudera talk to us a couple weeks ago. Cloudera is #1 vendor in Hadoop. That's big data. That's important. But they also use these kind of point-of-presence tricks to get you close to where you need to go. All that it is what we've done in factories for the last 30 years, distributed data over multiple processors. Okay, we can do it today faster. It's not new stuff, but without this, even that runs into a dead end. So these are force-directed graphs. It knows where you are. It gets close to the data that you want to see, then brings back only what you want to have. So big data is important, but little data, what I want to know, when I want to know it, is more important. And that's what this technology gives us. Let's talk about the journey. Take a look at the date. Those of you can read this. 10 September 2001. Mr. Rumsfeld was giving a speech in New York. This was his theme. It was all about needing an architecture to improve the efficiency of the business operation in the Department of Defense. The next day, things kind of changed. But they stuck to it, and started this thing called BMMP, Business Modernization Management Program. They spent a lot of money building architectures, $525 million. No one was happy with them. I discovered that, wrote a letter, and they asked me if I would come and help out. I came, that was in 2006. That architecture was the blueprint, the thing on the left side. That's all that architecture is, a blueprint. We have them for our homes. We had them inside of our GPS when we used it to get us here. If you're a pilot, it's your flight plan. We need those blueprints. But they're very complicated because people building them talk different languages. So that's what was happening in this BMMP thing. That's why they had all that money spent. The middle thing that we did was to, now let's focus on core business missions. So this is a hierarchical architecture that does work at the highest level, but it doesn't work at the detail level. You end up spending more and more money and it gets more and more confusing over time. This new way of doing architecture with the BEA is based upon this semantic web technology, end-to-end based, analyzed, executable, federated, and with consumable data from authoritative data sources. That's what the video is all about. That's what this project that Jonathan's going to be talking about on Tuesday and talked about last year actually proved. So 1.0 to 2.4 was boil the ocean. Even the department didn't have enough money to do that, but they certainly tried. 3.0 to 9.0 is prioritized. And those of you who are affiliated with DoD know you have to conform to these architectures. And it sort of got done, but there was no way to prove interoperability. NDA 2012 says we have to be able to prove interoperability at the system level of the architectures. So you've got your architecture at DoD, you have systems, you have solutions. Prove interoperability. That means that it isn't only the kind of connections, put two wires together, they don't spark. It's what do you mean? Do I know what you mean? Do I have to translate it, convert it? Can I afford to do that? We don't want the answer to be yes to any of those things. We want to be able to know the semantic meaning of that data the way that you meant it to mean and the way that I understand what you meant. That's what this thing on the right is going to do. I'm going to show you that trick. So it's executable. How? This magic, that when you obey the standards, the W3C standards, based upon pointing to the authoritative data sources using the OMG standards, you have the ability to answer a question like this. Each of these edges in this RDF triple store, Resource Description Framework, and each of these nodes has a precise URI. So I know who that Colonel Blatt is. And I can answer that question. Here's another data store. It's the same Colonel Blatt with the same URI. I know who he is, and I can answer that question. But now I want to know the pay grade with Colonel Blatt. What do? Add data to each data store. You heard me tell this story before, many of you. That would be our way in the past. But in the future, it isn't that way. Because we're using the standards, we can say, who has pay grade of 06 and has at least 24 months of dwell time? That's an important question. And whether you won't get an honest answer to, you'll get a believable answer, but probably not an honest answer. Pick up the phone and call your buddy. We've been doing it since I worked for the government years and years ago. So here's what happens with the technology. That. It's not magic because it's been designed in the past to work like that. And that's the graph merge. Normally that moves up really slow, but that was built on a Mac. When it moves up really slow, it's more dramatic, but you get the idea. That's what happens. Not magically, but with people obeying the standards, identifying authoritative data sources, by building a business process model that points to them, agreeing on the meaning that you had in your schema, and I had in my mapping ontology, and then writing the Sparkle query, the semantic web equivalent of SQL, to go to that authoritative data source, and to distribute the answer in some open social, we use Google or Ozone manner that's also very inexpensive. There was a memo written last April of 2011 by Beth McGrath saying that the BEA has to be built this way. And remember I talked about compliance, so when the BEA is built this way and it's complied to, then what I just said will be doable as each of the new systems are being built as they come through the compliance process. So all this does is point to the exact technology. Now the fact that we got a DUSD, instead of confirmed person, to put these kind of words in a memo to go through the department? Why wouldn't we do that? It's certainly possible. And I hear that all the time. We can't be using these words in front of the seniors. And I'm about to retire, so I say, bull, you can add the last word. We can. And when we do, others follow. But we're not alone. This is from the CIO. They've said the same thing over the years, but they didn't say how. They've said how to do interoperability, connect the wires together, no spark, we can test that, that works. But we've said that's not good enough. We have to be able to interoperate at the meaning of the terms. What do you mean? Do I know? Without changing anything that you wrote, without changing your schema, without throwing out your database. What's wrong with that? The technology works, DARPA invented it, all we have to do is use it. So here's the one slide. There'll be a few after this, but the one slide that should prove the point. There's the BEA, lower left-hand corner. That's an enterprise architecture at my level. It has the three most important moving parts, although there are 52 DODAF views. It has the business process model using BPMN at the top. It has the data. It may look like an OV7 or a diff3 to you. It is the data that we have within the BEA that will be in our RDF triple store. And the most important part is the mapping ontology. The mapping ontology, using more standards, points to the authoritative data sources that are the other architectures. So here's one. Here's the DIEA. Brian will probably be talking about this tomorrow when he comes here, Brian Wachinski or Walt Ocon. That's their architecture, built to the same standards. We confederate. They both appear to be the same when you ask a question. They're not. Here's another one. This is the Human Resources Management and Enterprise Architecture. Appears to be the same. It's not. But it uses the same standards. And here's another one, where we're spending most of our money probably in the next 10 years. IEHR, Integrated Electronic Human Health Records. Most of the money, because people are coming back from the wars, and many of them, unfortunately, are hurt in some way. So that is the left side of this picture. That's the part that is OSD level. The right side is the most important part for things like interoperability. So on the right side, we have a solution architectures. We've tested this with virtual input processing system. The guy who was in the video, that was his project. How you build a solution architecture, according to our rules, and I would do the same thing as I did in industry, is you go to the corporate architecture and you see what is in there that I can use. What data, what processes, what concepts and semantic web terms, meaning of the data, what can I use? And you transfer that to the right side. As you go to solution architecture, you put back what you learned from the solution architecture. For example, it would be IPS. This is the Integrated Personnel Pay System, the grandchild of Dimers. Same thing happens there, or IEHR, or whatever. So you go to the left side, populate the right side, build the right side, put it back into the left side. It's simple. You invent a new tool, put it back into the big toolbox. Next time someone else can use that tool. We've talked about interoperability. We've talked about reuse for decades. Didn't have the technology. Now we do. Will it get better still? Yeah, sure. But we have it. It's good enough now to be doing these things. The point of view of an investment review board, the upper left-hand side, those are the gadgets. Those are the visualizations. Not how I pre-programmed it 2 weeks after you asked me the question, but how you can go to open source tools and how you can point to the authoritative data sources through the architecture whenever you want to know the answer. The same way that you do today, using global search like Google has, or the moving to semantic web, or from Alpha, an exact answer to an exact question that no one thought to ask before, but the way that systems are developed, you can get the answer, the exact answer to the exact question. So DoD policy. This is in the memo that I told you about on April 11th of last year. And the point of this slide isn't to go over the standards again, but when you see the hard copy or the on their website, TTR website, this is the simplest website that I've seen that explains this technology. So write it down or look it up when you go to their website. It's very easy because it builds one on top of another, one piece on top of another. All based upon standards. I didn't need to make any of this up. We didn't need to put some pieces together, perhaps for the first time. The fact that it begins with Star Lab is pretty cool itself, I think. So go there. All the answers, what I'm talking about, are there. We need some ontologies. Look up the word ontology. It has to do with the basic meaning of life. Well searching for that, and have been since we discovered this planet. So forget about that. All that it says is that we understand one another. That's all that an ontology is. It's a precise meaning that we've agreed upon in a particular context. Like the word tank. I fly airplanes, you all know that. Kind of the tank that's on the airplane are important to me, 3 or 4, and how I use them. Also the one on the ground, the tank of the truck, or the tank that just cleared the field so I could land where I want to land. So the meaning of the term within context, that's all that an ontology is. The data can stay the same in our RDF triple store, but then there's another thing called OWL, Web Ontology Language. What does that data mean in that context? We're training people, we've trained 300 and some. It's free. We call it equipping the workforce because training isn't in our lane. We figure out how to do things. Equipping the workforce. We've trained more than 300. It's free to contractors and the government people. We don't care where you are. Talk to Dee Dee, talk to Eric, talk to Jonathan when he gets here. Ask them how to get involved. These are different ontologies, different purposes. The most important ontology for us right now is the BPMN 2.0 ontology, Business Process Modeling Notation 2. That says that when we write down an activity in a business process model, and we say where that activity goes, does it trigger an event, for example? What kind of event is it? We can tell exactly what it means. You can't fool it. Because the rules for that business process model are in that ontology, precise meaning, anybody can read it, and machines can read it. That's important. The content ontology is important, the BEA. That might be good enough for us. But that Federation slide, the Federation slide says we have to be able to go from our BEA to anybody else's. How do we do that? We have the DODAF, the Data Architecture Framework. DODAF has a thing called DM2, the Data Model 2. We have to obey the Data Model 2, and in theory, you can go to from any view to any other view where the objects are the same, classes are the same, using a DM2. The trouble is, there was never a DM2 ontology. What's the ontology? The meaning. The meaning. So we're building, with the cooperation of the CIO, a DM2 ontology. By the way, the VPMN ontology is going to be an OMG standard. Pushing these things out so that they aren't ours. I've been through DoD trying to establish standards. The IDEFs worked. It was a long time ago, they were very simple. These things are more complicated. We need to put them in the public domain, and we are doing that. There'll be a BPMN 2.0 ontology, DM2. There's a DM2 2.02 ontology, about 50% baked. By the middle toward the end of July, kind of you to make it happen. I'll be in Chicago. There'll be a DM2 ontology, 2.03. In this one slide, maybe this one or the next one, there's a pointer to those ontologies. All this has to be in the open or it doesn't work. These other two that are there, the H2R and P2P, those are higher retirement period pay. Those are end-to-end business process models that are in the current BEA. They will also have an ontology. So another picture that builds the big picture, the cloud. All of this must work within the cloud, just like the video says. If there's no cloud, this doesn't happen. When you see Jonathan's demonstration on Tuesday, ask him where all those processors are that are doing all those things and where they were during development time, on and on like that. And that stuff's going live next Friday. That's my going away present. Live. I've had this retirement thing on the table for 9 months, but I wasn't going to officially do it until we had it actually working. So it'll be live. So it's in the cloud. This picture shows what I've said. Execute the business process model. The user's on the upper left-hand side. He or she, that's a woman's picture there, goes into the BEA through the DM2, and then the software takes the question where the answers are, and delivers the answers back. That's all that picture says. And the warfighter's in there as well, because that's really the business where we spend most of our money. And so we're building these ontologies. I've already told you this story. Here's the most important part of this slide. It'll be in the hard copy. If you have a CAC, you can go to forge.mil and find this. If you don't have a CAC, you can email one of the guys or girls. I call it guys for guys and girls, and they'll send it to you. But all this needs to be in the open. Otherwise, it stays the way that it was, controlled by the computer priest, and we don't want that anymore. So, watch for DODAT 2.03. It'll be out in draft form because they have a very elaborate vetting process, but at the end of July, but I don't expect it'll change much after that. You'll be able to use it. So, one last couple of examples to really drive this home. We have these droids or these iPhones or whatever else we have, and we have things like Siri or Evie. If you have a droid and others, and people talk about how wonderful that thing is. You can ask it a question, it comes back. Voice recognition invented by DARPA is a useful thing, except all that it's doing is confirming that that computer understands what you're asking it. That's all. The most important part is you have that thing in your hand, you're talking to it, it knows where you are, it knows who you are. But as someone said over here in this Apple Droid thing, the application is really running somewhere else. And that's how we manage the security part of it. So if you ask me for the most romantic Italian restaurant in Alexandria, it doesn't care about what's happening in New York City. It knows only about Alexandria. And it knows about those restaurants who have obeyed the rules to allow you to know that your favorite table is ready, that your favorite wine isn't. It can tell you all of those things with today's technology. You can have around me. Around me is another thing. What's around here? Not much, but what there is, it'll tell you. Are there any birders in the crowd? She came here to see a pileated woodpecker, and I disappointed her last night. We went for a walk in the woods, and we tried it again this morning, because they're supposed to be here. If anyone goes up in the woods and sees one, doesn't know. So they're not in the around here. I wouldn't expect them to be. SkyMap. There are stars up there. Anyone use SkyMap? Yeah, here's a guy here. These are free apps. You want to know what constellations are in the sky, what stars are there? SkyMap. It'll show you. Turn with it in your hand. Hey, there's where Venus is. It'll tell you. These things are here today. Evie is the droid version of Siri. They're here. So, how do you build them? Those of you who are vendors in the crowd, can I expect to see something like this in a DoD RFP? This is the whole architecture. All the pieces that have to be there, that are there in commercial systems like Watson, or Siri, or Evie, or SkyMap, or Around Me. These are the architectures that they use. Now, the details might be slightly different than every one of them, but these are the architectures that they use. So I have my soldiers up there in the upper right-hand corner. What about them? I'm sitting on a hill in Afghanistan. I'm getting low on, could be ammunition or batteries or food, and I need some help. What do? Call on the radio and hope for the best. Call into the blind. They ask me where I am. I think I know. I might not. Or do I have one of these point-of-presence devices in my hand? And they know precisely where I am. They're watching everything around me. And they say, I know you say you need a convoy within 24 hours. There'll be a sandstorm in 12 hours. We can't do it and risk other people's lives. You're going to have to wait 38, figure it out. 36, figure it out. What's wrong with that picture? We can tell, if they can tell me, if this technology can tell me the best Italian restaurant in Alexandria, why can't we tell our troops exactly what they need to know, when they need to know it, do what they need to do, when they need to do it? With today's technology, the way we're using it, we can't. With this technology, the way that I hope I've started this journey, we can. So with that, thank you very much. Happy to answer any questions. Where's Parnham go?
So isn't this just like virtualization of the data?
Is it like virtualization of the data? Yes, it is like virtualization of the data, but it's much more than the virtualization of the data. It's virtualization of where the decisions are allowed to be made as well. It's virtualization of everything. What I did the heading analogy and Airspeed thing, it isn't because I'm a pilot, but it really takes three things to make most things, like the Panama Canal, I won't worry about the story, but look it up. Three things it took to make that happen. Every successful venture of mankind, personkind, has taken three things to make it happen. What was the most important thing for the Panama Canal? Actually, all three are equally important. What were they? One, no?
The goldfish.
The what?
Gold.
Gold? No, there's no gold.
No, G-O-A-L. Gold.
Well, the gold, yeah, of course you have to have the vision. It took nitroglycerin, the Nobels, dynamite. It took that. It took quinine. The guy went to the same high school I went to, invented that. Because of malaria, it took one more thing, which has really been my job. Panama didn't exist. We had to create Panama. Didn't exist. So it took those three things. Someone else had a question back there, sir.
As you well know, in the Department of Defense, the culture is, this is my data. You ask the question, I might give you the answer. If you don't ask it correctly, I may not give you anything. How do you break down those walls to make information really shareable and available to anybody that needs it? As long as there's no classified reason not to.
Right. Unfortunately, we can't do it like we had just had an agility forum under Paul Brinkley, and he had Lou Gershon, right, the former IBM chairman of the board, and someone asked him that question, and he said we fired them. And so we can't exactly do it that way. I mean, that was interesting. But what we're saying, the real objection is you can't change what I meant, and I know what I meant and you don't. We don't ask them to change the schema. That stays there. And we say, is this what you mean? And we take that meaning and put it in the mapping ontology. And so when the answer we get isn't the answer that they told us we should get, then we negotiate. And when Jonathan shows you EIW, he'll show you the little red X's where we point to people that, hey, you told us this answer was going to be Z and it's M. Is the data wrong?
I don't want to share with you.
Well, but we're becoming that. With these, when you come to an IRB, Investment Review Board, and you aren't compliant, and we couldn't prove it before, now we'll be able to, you don't get the money. So the thing that wasn't able to be shared because they didn't want to goes away. It may sound a little Pollyannic, this isn't going to happen overnight, but it's going to happen. We have the power of the purse in the business mission area. And I've heard the same I've heard others in the warfighter mission area and EIDA say the same thing, that they're getting, like JIE, Joint Integrated Environment. It's going down the same road. Has to. Anybody else? Sir.
I guess as a follow-up on that question, I guess there are a number of things in the markup language that you can do to facilitate, like putting temporal in the our markup language, or geospatial, so where something happens, when something happens. The question would then be, one of the questions I would have is, how are you differentiating with the authoritative sourcing? Just as the example, using your airplane analogy. If I'm a Navy pilot, you're an Air Force pilot, and we're doing the Joint Strike Fighter. If I say shaved cat, you get a certain perspective, whereas the Navy pilot, we're shaving back power on the catapult. And so how do we...
What's the Air Force doing? What's the Air Force guy doing with a shaved cat?
We're not going to answer that. But the consideration is the authoritative for the Air Force staff may be different. And so is there an employment of feature vectors that would suggest that my request should be managed and handled differently within the OWL architecture than his request?
Yes. A very simple answer to a complicated question. There are the authoritative data sources have a mapping ontology to the thing called the Sparkleizer that is open source technology that we developed. Now, every time we do that, of course, commercial people say, we'll do it in the open as well. Let's talk about the preferred answer. So a Sparkleizer takes those two answers and says, here's what the Air Force meant, and here's what the Navy meant, and here's what the Army meant. Yes, it had to all be figured out. And there's also above that a thing called a federator that brings the answers back to the one answer that we want at the USD level. Yes, and that's what we've been doing. So the EIW has been 10 pods, proof of delivery, one every 90 days for the last 3 years. And if you'd asked me that question 3 years ago, I would have said something like, damn if I know. But every time, every 90 days, we get further, we get closer and closer to here's how this has to work. With lots of industry people, of course, helping. Sir?
These semantic architectures be applied retroactively to existing data, or is it only a go-forward model?
Retroactively. There's a thing called R2RML, relational to markup language mapping, I believe is the right. And it's a W3C standard, and it says that you take your relational data store, your data tables, and you turn that into an RDF triple store. And why you want to do that is because when the RDF triple store is the graph that I showed. When you do that, then you can access that relational data store as though it was a graph. And you can link it automatically to other native graphs. So yes. Now that was also an answer I couldn't have given you a year ago. But now we can. We are not writing any of these specs, but we are standard. We certainly are influencing them, pushing them in directions that are scalable for our size. So yes, if we couldn't answer that question, I couldn't be standing here because this is going to be around for a long time, the relational stuff. We're not going to, couldn't afford to change it even if it makes sense, and it doesn't. Yes, sir?
Sorry for Dominic. How long do you think it would be before there's a mass adoption?
The question is, speaking very quietly, how long before there's a mass adoption? There is a mass adoption. Unfortunately, I probably shouldn't use the word unfortunately, but even in the companies that are doing it, some people running these big companies don't understand, are included. We went to the chief scientist of a big company that has two little eyes in its word, and said, do you know that your company bought 3 semantic technology companies? He didn't. When you go to YouTube and you type my name in there, right under me is a company called Metastorm, I have that right, Dee? They were bought by Google 2 years ago, and Google is moving very rapidly in this direction. So this is mass adoption. Yahoo, a year ago, we checked in them, they were 28%. They said 28% of internet searches are now based on this technology. I'm sure it's much higher. Now, the Siri stuff, the Watson stuff, all of that is moving in this direction. It just has to. Just makes sense.
I think the other question might have been, instead of that, just commercial is mass adoption, but how do you get mass adoption within DoD?
Okay, mass stuff within DoD. That's a harder question.
Sorry, did you just want the easy one?
Again, I can afford to be either one of 2 ways here. Very Pollyannish, it's really going to happen with spite of me, or, my God, I'm reading, it won't. I choose to be positive. Eric's with this now. Eric?
Yeah, I just wanted to point out that mass adoption has already happened in the intelligence community, it's just not shared.
Yeah. And the Intel, of course, I should get the Intel, being an engineer, of course, when I discovered what I believed we had to do, I don't want to fail. And so we went around and said, who's doing it? DARPA invented it. the Intel community was the cause for it. It's all over there. They don't talk about it much, and of course they'll take many shortcuts because they have to. But for real mass adoption in business, we have to take the long road. We have to bring people along slowly and obey the standards. I also, Eric has an enterprise architecture steering group, that what's called?
Yes.
It has. I spent yesterday morning there with them, all over this. So this is happening. The contractor community, when we started to talk about what we were doing, many companies came right out of the closet, I'll use that word. I've been doing this for 5 years, we were afraid to talk about it. It's happening. Has to. Okay, I don't see any more hands. I'll be around for the next 24 hours or so. Might have lived in Chicago? Well, I've lived in Chicago. I originally grew up near here, they said, and we moved from Dayton, Ohio. I worked for Wright-Patterson for 10 years in the 70s, where all this IDEF stuff came from and architectures. And then we moved to Chicago to totally escape DOD, and did until I wrote that letter to Rumsfeld. And so I've been commuting and living in Alexandria for the last 6 years, first as a contractor. And so I intend to spend, and she's been living in Chicago. Yes, dear.
Would anybody like to buy a local town?
Oh, yeah. Does that answer your question? Condom in Alexandria. So it's time to spend more time there. I want to reverse my commute. I intend to stay involved, obviously, in government, but reverse my commute. Spend more time there, less time here. If I had my way, I'd be in California tomorrow with our grandchildren, but she won't do that. Here we are. Okay. Again, thank you very much. It's been a pleasure working with you.
All right, thank you. Thank you, Dennis. We have a bit of a break here. Our next session started around 3:30. In this room, we're going to have a panel called How to Trust Your Cloud Vendor Security Strategy.